Hello APC Mechanics students, today we will solve exercise 1, past paper of RQ 2007. Then let's start with exercise 1. So mechanics 1, a block of mass M is pulled along a rough horizontal surface. So the surface is rough, which means that we have friction. By a constant applied force of magnitude F1 that acts at an angle theta to the horizontal as indicated above. So this is the figure. This is the block of mass M. And this is the applied force making an angle theta with the horizontal. The acceleration of the block is A1, so the block is being accelerated. Express all algebraic answers in terms of M, F1, theta, A1, and fundamental constants. So this is important. Now whenever we achieve a result, we need to check whether this expression is expressed in terms of these quantities. Now on the figure below, draw and label a free body diagram showing all the forces on the block. Then what are the forces acting on the block? Because the block has a mass, then it will be subjected to the pull of gravity, which is downward. It's being placed on a horizontal surface. Then we have the normal push, we have the force F1, and the block is being accelerated, then it's moving. Then we have the kinetic friction. If this is the force F1, then the direction of motion to the right, then friction will be to the left. Then let's represent the forces. Here we have the pull of gravity. Now remember to represent the forces using a ruler. This is the pull of gravity downward, then this is Fg. Let me make it even smaller, or let me say the following. This is the pull of gravity. And remember that we need to label the forces by their names. Now we have the forces F1 making an angle theta with the horizontal. Now here, it's not important that we place the angle, but let's do so because we know that we're gonna use that whenever we need to solve for a Newton's second law, for example. Then this is the angle theta. And remember that we don't represent the component of the forces, we only represent the forces itself. We have the normal push upward. Okay. So notice that I have represented the normal push in the sense that the magnitude of the normal push is not equal to the pull of gravity, and this is due to the fact that we have another force F1 having a vertical component. Then basically the vertical component of F1 plus Fn would be equal to the pull of gravity. And now I'm gonna represent the force of friction, which is to the left. Then let me say this is friction. Alright, and this is it for part A. Now in part B, derive an expression for the normal force exerted by the surface on the block. Then we need to determine this expression, the expression of the normal push in terms of M, F1, theta, A1 and the fundamental constants. In order to do so, we need to consider the fact that along the vertical the forces are balanced. Then what do we have? We have the pull of gravity, which is downward, and the pull of gravity is being balanced by the normal push, which is upward, plus the vertical component of F1. Now theta is the angle with the horizontal, then the horizontal component would be F1 cosine theta, and the vertical component would be F1 sine theta. And in this case we are interested in searching for the magnitude of Fn. Then Fn in this case would be given by the pull of gravity minus F1 sine theta. And due to the following statement, we're gonna replace the pull of gravity by mg, then the normal push in this case is given by mg minus F1 sine theta. And here let me state that this equation holds because they are balanced forces. There is no motion along the vertical direction. So it's important that we justify everything. Then this is it for part B. Now in part C we need to derive, and sorry, you can always check that indeed our expression is given in terms of m. G would be represented as a fundamental constant f1 and theta. However, for A, now it's not necessary that our expression would be expressed in terms of all of these, alright? Now in part C, derive an expression for the coefficient of kinetic friction between the block and the surface. Then in this case, we know that friction is given by the coefficient of the friction. In this case, this is kinetic friction denoted by mu, multiplied by the normal push. Then we are interested in determining the expression of mu. Then mu can be written as the force of friction divided by the normal push. Already we have obtained the expression of the normal push from part B, and it's left to determine the expression of the frictional force, and this can be done by considering Newton's second law along the horizontal. Then let's apply Newton's second law. Apply Newton's second law. And what does Newton's second law says? It states that the net forces is equal to the inertial mass given by m, which is basically the mass of the block. It's being denoted by m, multiplied by the acceleration, which is denoted by a1. And now we're gonna replace f naught by all the forces that are acting on the block given by these four forces. Then we have the pull of gravity plus the normal push plus the applied force F1 plus the friction force, and this is equal to MA. Now we're gonna project along the x-axis, so projection along the horizontal, let me say. Now the pull of gravity is acting downward, it has no projection, and the normal push is being acted upward, so it has no projection. Now the force F1, yes indeed it has a projection because it's making angle theta with the horizontal. Then the projection would be given by F1 cosine theta. Now what about the force of friction? We have a minus sign because it's acting in an opposite direction, and it's completely parallel to the direction of motion, which is supposed to be to the right. Then we're gonna say if the right is positive, then this is negative, and this is given by FF is equal to MA1, then this is 1. And recall that we have the expression of F, and we are interested in determining the expression of FF in order to determine the expression of the coefficient mu. Then we are interested in finding FF. Alright, now we're searching for the expression of the frictional forces. This can be dragged to the right and this is to the left, and then we're gonna have F1 cosine theta minus MA1 is given by the frictional forces. Now we can swap left and right members, and we have that the frictional force is given by F1 cosine theta minus MA1. And remember that in order to determine the coefficient of the friction, we need to have the expression of FF and the normal push. In the previous part we have determined the expression of the normal push, and now we have the explicit expression of the frictional force. Then the coefficient in mu is given by what? Is given by the ratio of friction over the normal push. Friction is given by F1 cosine theta minus MA1, and the normal push from the previous part is given by MG minus F1 sine theta. And you can double check that we have expressed our answer in terms of m, let me say m F1, A1 and theta, and the fundamental constant given by G. Now on the axis below, sketch graphs of the speed v and displacement x of the block as function of time t. If the block started from rest, then the initial speed is 0 and the initial position is 0 as well. So basically the graphs in both cases will start from these 2 points. Now in order to sketch the graph, we need to understand the type of motion by referring to the acceleration. Now here in this case they're mentioning that the acceleration of the block is A1. Now we need to make sure that A1 is constant. Now A1 is due to the forces applied on the block. Because the force F1 is constant, and we know that the kinetic friction, which is backward, is also constant. Constant minus constant, it is a constant, then A1 would be constant as well, because whenever the forces are constant, this would yield a constant acceleration. Now the block is moving to the right, then we're gonna assume that the acceleration is positive. Then here let me say that we're gonna move in the order from 0 to constant to linear, then to quadratic, and the order that we're moving with is from A to V to X. Now remember that this is not part of the answer. After we do the sketch, we're gonna erase them. Then if A is constant, V would be linear and X would be quadratic. Now A is constant and we're assuming that the motion is to the right, which is positive, then it's gonna be shift. Okay, so we have acceleration is positive, which means that V would be linear, either like this or like that. A is positive, then the shape of the VT graph would be something like this. From which point we're gonna start? We're gonna start from this point, then that would be the shape of the VT graph. Now here we don't have any values for V or T, so we're not gonna put any labels. Now if V is linear, then X would be quadratic. It's gonna be either open up or open down. A is positive, so it will be open upward. We have several choices. It might be like this or even like that, and this depends on what is the sign of V. V is always positive, which means that the position is gonna increase. So the position will increase, and in this case, the shape of the curve would be like that. Which is a parabola open upward. And because we know that these are not part of the answer, let me remove them. And finally, now in part E of this exercise, if the applied force is large enough, the block will lose contact with the surface. Let me explain that. Now they're saying that if F1 is large enough, the block will lose contact. Why? Because F1 has a vertical component. As F1, the magnitude of F1 increase, this will pull the block upward, which causing it to lose contact with the surface. Now derive an expression for the magnitude of the greatest acceleration. We need to find the acceleration that the block can have and still maintain contact with the ground. Then we're talking about the limit of maximum acceleration, and we're about to lose contact, and this happens when the normal push is equal to 0. Why? Because the normal push is the indication that the block is in contact with the ground, because it's a contact force, and it comes from the fact that the box is being in contact with the ground. Then in order to find the expression of the acceleration, we need to refer to this equation. Now F1 cosine theta minus MA1 is equal to the frictional forces. Now the normal push is equal to 0. What happens next? We know that the friction is related to the normal push via the coefficient of kinetic friction, and if the normal push is equal to 0, that means that the friction is also 0, and this is reasonable. Why? Because friction is also a contact force, and due to the contact between the block and the surface, the moment we start to lose contact, then the frictional force will be set to 0 also. Then what we're gonna have here is that F1 cosine theta minus m, and this acceleration would be the max. We need to pay attention and use the same notation, and this is equal to 0, and we're searching for a max. Then we can move this to the other side. F1 cosine theta would be equal to ma max. Then a max in this case would be given by the ratio of F1 cosine theta divided by the mass of the block. Then that's it for me in this video, guys. See you soon in a new one.